Yeah, happy Monday, everybody. It's a good day to be a Soroban developer, just like every day. There's a service called Mercury, which is a data indexer. I'm super into data indexing right now. It's a huge part of developing interfaces off of contracts because contracts store data, but the data is stored in confusing XDR formats and is not very queryable, which is where indexers come in, which is essentially taking blockchain data, pulling out the pieces that you actually need and putting into some sort of sane format. My favorite indexer at the moment is run by a team called Mercury. Well, it's actually Zyclu Labs, but they have a platform called Mercury. They've got this particular service called RetroShades, which is a really, really interesting tool for basically taking events, contract events, and converting it into Postgres databases. Very, very interesting. And I've run a couple of demos with it, but that was like 2 or 3 weeks ago. And just tried to spin my demo back up and it wasn't working. So won't be able to run a demo on that, but something to definitely keep an eye on. Just put a link to it in the Discord chat. Being able to figure out how to get data off-chain and into an application is critically important. And it's not necessarily super obvious. But with Mercury, they have a VM, Zephyr, that is like a parallel network to the main Stellar network that allows you to ingest ledgers as they close and then take that data, do a bunch of processing, and then spit out something into a database that you can then query. I've built a couple of different versions of this. Let me show one. One is inside of the passkey kit. So smart wallets have multiple signers on them, and those signers are emitted as events. So if I get out of the demo here and pull up the contract interface, let me pull up the wallet itself. And then we look at events. These events are what I'll end up ingesting inside of Zephyr. And it's strictly for tracking signing keys. And this allows you to do things like reverse lookups. So given a passkey ID, I want to find the contract ID that it's associated with. It emits these events, and then Zephyr will look out for those as it's processing ledgers in its own like parallel network. And then what you can do with those is then build out a database that says this kind of like reverse lookup, either give me a contract and show me all its signers, or give me a signer and show me all of the contracts that have added that signer. So there are different events: add, update, remove, and then those then get processed by the Zephyr indexer. So the indexer is like its own, almost like a pseudo contract, but it's not a contract, it's just a program, a Rust program. You have access to way more stuff, which is super cool, than you do inside of like a virtual, or inside of the Soroban VM. And in my case, basically all you're trying to do is you're given this reader of Soroban events. Zephyr makes available basically when the ledger closes, this on-close method is fired, and then you can begin to process things. One of these is a list of Soroban events, but because it gives you every Soroban event, you have to start filtering down from all the Soroban events to only the ones that you're particularly interested in. So that would be things like, I have a tag that I tag all of my events with that is a filter. I've got a couple other filters here based off of what function was called. But that's what all of these if statements are for, to eventually boil it down to the specific contract that I'm after, and then the individual methods that I'm after. And depending on what those methods are, I can read into a database for things like adding and updating signers or removing signers. And you can see what it's basically doing is going into that database, looking up some columns. These are it's like an API for doing Postgres queries. So it does some filtering off of the rows, so that when it does an update or a delete or something like that, it's actually deleting or updating the right row. And then eventually so that's like the program that runs every time a ledger closes, just looks for events and adds, removes, updates signers in that custom database. And then I've got these little serverless functions, which are basically functions that are hosted by the Zephyr service, or the Mercury service, I guess, that then creates an endpoint for you for things like getting signers by address. It takes in an argument that matches this type that I've written, which is like get signers by address. So you just pass in a single address, and then it will get a list of signers that are associated with that address and give you back a response, which is an array of those signers. It does some processing to make it more JSON-esque and less XDR-esque, which is nice. And then you finally push back that response with your array of all of the signers that are associated with that address. So that would be one serverless function. Then I make another serverless function for getting addresses by signer. So it's like that reverse lookup. Given a signer, give me the addresses. There are different types of signers. So depending on the type of signer that you're passing in, it will process the request a little bit differently. So that's a way, if you're using Zephyr to host your database and you want to build a database inside of Zephyr. This is not, for what it's worth, all of this stuff, this what is it? 270 lines of code. It's a lot, and it's very, very programmatic. Like, you can get exactly what you want. But one of the reasons that I'm quite excited about RetroShades is it's code that runs, this like Zephyr shadow events, runs right inside of your contract code. So you don't actually have to deploy a Zephyr program. You just deploy a contract, and you deploy the contract both on the Stellar network and on the Mercury parallel network that actually holds your shadow events. And then those, whenever the shadow event gets called, it actually builds out a database all on its own. So you don't have to do all of this stuff. And then you can just send it raw Postgres queries. Again, I'd hoped to demo that, but it doesn't seem like something's not quite up at the moment. So hopefully we'll get to that another time. But all of that to say, let me see if I can find really quick actual code for the difference that I'm talking about. And this is a contrived example, but basically you've got a contract, and then you've got these RetroShades where you define a struct, like an event struct, inside of Zephyr, which is going to essentially be like your table. And these items that you put in there will be rows. And then you, instead of just emitting a Soroban event, you wouldn't even need to submit a Soroban event. You could submit this RetroShade event, and it will add another row to your table whenever that event is triggered. So it's not as flexible if you wanted to do like build out custom databases or update rows, things like that. But if you just need to strictly add additional rows and then do, I don't know, processing or something later, this is like a really easy way to do that. So like building out historical graphs and stuff like that. And this is all you have to do. There's no additional Zephyr or Mercury specific code you have to write. You just write your contract, and then either in another contract or even in the same contract, you add in Mercury elements and then begin emitting these RetroShade Mercury events. And it automatically builds a database, and then you can, there's an API that gets automatically built for you on the Mercury backend, which allows you to submit raw Postgres queries straight to that database that was built. So very, very quick way to begin indexing contract code. Another super cool thing about this is you don't have to own the code. Like, you could go and clone someone's contract, retroactively go back and add RetroShade events, and begin indexing somebody else's contract. So if let's say you've got, I don't know, the blend protocol, which is always what I'm going to go to, and you wanted to look at historical metrics or something, but you don't actually own that contract, doesn't matter. You can just clone the contract code, go in there, write whatever events you want, and then upload that contract to the Mercury parallel chain. And then anytime the actual Soroban Mercury contract is blend contract is called, this parallel one will also be called. It'll find all of your RetroShades and begin building out a Postgres database off of that those blend executions or blend invocations, which is super, super cool. Building out custom logic that then you could begin to use for custom responses, either building out dashboards or actually submitting transactions or making decisions. So those are like the two. That's two items. That's one of those is a little bit different. I'm going to make sure I don't save any of that. There's one other item that I want to talk about. Well, maybe two in this regard, and the other one is I'm building have been building for a long time. Is this the right one? No. A NFT Web3 game called Color Glyph, and I've got a Mercury indexer running on this. Oops. Where is it? Here. But what I do here in this particular one, it's a pretty long one. There's a lot of different events. It's a pretty complex contract. But instead of having Mercury or Zephyr host my database, I have it forwarding to my own database. So it finds all of the data, processes it all, and then uploads it, sends a web request with like any of the changes or the updates, and sends it to my own backend service, kind of like a webhook. So I can populate my own private custom database with all of my own data without having to rely on Mercury for the Postgres database, which is sick. You could also have this send to a Discord bot or your own database, other bot responses. Heck, you could upload it to an AI model or something to feed into wild stuff that you're doing, which would be pretty cool. So you can kind of exit out of just use Mercury for ledger processing, and then whatever information it ends up spitting out based off of all the other criteria that I have here on doing data matching, spits out a final result to a database. So you can have a really clean database with updates and deletes and whatnot, but all stored off of the Mercury side, which could make your front end. In my case, it'll make my front end much faster because I can cache it however I want. So data is coming in, but how that information actually ends up showing up to the end user comes straight from my database, rather than me having to rely on the uptime of Mercury for actual delivery of the database. Which is super cool. Another thing that I want, maybe the last thing to call out, and this is something that I've been thinking a lot about as I think about smart wallets, AI, and Mercury, or particularly the Zephyr VM that Mercury has, is this concept of like autonomous wallets. There was an article, I'm not sure I'm going to be able to find this article quickly enough, but there's an article that TDEP wrote, who is behind one of the devs behind Zyclu, which is one of the devs which is the team that built Mercury. He wrote an article on these like smart wallet autonomous wallets, where essentially you can fill up a wallet with some funds, point it at something like the Blend protocol, and because you have access to on-close ledgers, so like every single time a ledger closes, you can execute some arbitrary Rust code because you write the program. You could essentially be like looking at the Blend protocol, listening for inbound, deposits or withdrawals, and then with a smart wallet, actually begin interacting with that Blend protocol. So you fill it up with some assets or whatever, and then based off of the inbound deposits and withdrawals, start to actually make transactions, because submit transactions. Another thing that you can do inside of one of these on-close methods inside the Zephyr VM is do transaction simulation and transaction submission. So you don't need the JS SDK, you don't need the CLI. You can literally listen to inbound requests, use your smart wallet, and start to execute simulations and submissions of transactions, all without a user having to be involved at all. It's like these automated bots that run right at the edge, like the bare metal ledger, which is super cool. Like most of the time with like Horizon or something, you have to wait, or the RPC, you have to wait to ensure that the data has actually been ingested and processed appropriately and then delivered. So you might be quite a bit behind the actual ledger close. But with the Zephyr VM, as soon as that ledger closes, your program executes, which kind of like makes you first to whatever just happened. on chain, and then pairing that with these smart wallets, you can then actually do transaction. You can build a new transaction based off of the information that just came in, and then execute that operation on chain in the next ledger, which is super, super cool. And again, there was an article, and I don't think I'll be able to find it, but if you go to mercury.data.app, they probably have like a link to a blog. Yeah. Oh, here it is. Well, kind of. Here's that. There's all kinds of wild inspiration that's going on in here. And something that I'm really, really interested in exploring is kind of merging that with this right here. Oops. This Coinbase agent kit, which is like this AI agents, autonomous wallet. So you basically feed AI, where you like put together the ledger or the blockchain with an AI model and a smart wallet. You put these three things together and just like see what happens. Obviously they're like specific use cases, but something that I'm really, really interested in. Just like giving a bot access to the ledger, like ledger data as it comes in, as the way that the AI model's trained, give it some money and then just see what happens. They've been doing this on Ethereum, and it's been like, it will autonomously make meme coins, and launch it will launch its own token and its own campaign for these meme tokens. And I just think that's so wild. I'm very, very terrified, but interested in this merging of really, really closed ledger, like you have access to immediately when the ledger closes, all of that data, all of like the ledger data fed into an AI model with the attachment of smart wallets, so that a user never has to be involved. You add on to that things like policy signers inside of those smart wallets, and then you restrict, like, okay, Mr. AI bot, you can go crazy, but not that crazy. You can only interact with this asset, this amount, these different protocols. Like, you can give it some really restricted parameters for it to then just like go nuts and train itself and learn and launch tokens and try and make money off of different DeFi protocols. There's a lot of really interesting work that needs to happen there. And I think it's going to be so much fun. So I'm just feeding all of that information to you all to go crazy with, because we have these pieces in place to do some really, really wild stuff. It's just a matter of exploring and tying those pieces together. And very likely some of this stuff is going to end up in like our strategy for next year. So you'll probably see us talking more about this at things like hackathons and in blog posts and whatnot, is exploring different novel use cases of smart wallets, AI, the Zephyr VM, things like that. Okay. So that is all the things I'm not going to talk about, because Zephyr's currently not working for me. There was an item, Elliot, that you had put into a document asking about like what data should be stored on chain, what data should be in event. I think that was you anyway. Could have been.
Yeah, I think so.
Yeah, I think that's a good one to just kind of talk about. I don't know, maybe if you want to either ask any follow-up questions on Zephyr if I missed anything, or Mercury, and then maybe just provide some context to that question for folks.
Yeah, on Zephyr, like if my experience with Rust has been limited to Soroban, like that's the only thing I've really ever built with Rust.
Mm-hmm.
Is there a heavy or steep learning curve? Because this is like the Zephyr program is just kind of bog standard Rust as far as I can tell.
Yep. Yeah,
what's it like to go from Soroban to that?
It's gentle, but it is a bit of a learning curve. Only in the sense that you can do any Rust thing. It's a standard Rust program, so there, like, you have access to the standard library inside of a Zephyr on close or a Zephyr program. So it's one of those things where it's like, yes, you can do as little as you do in Soroban, or you can start to do crazy things outside of that. So access to the open internet. So you've got async requests and threads and memory and allocators, and there's some pretty cool stuff. But I will say most of the stuff you're probably doing is just grabbing ledger data, processing it in some way, and then storing it somewhere or sending it somewhere. So there's really not, like, from what the experience that I have had, there's not a whole lot of crazy things you'll want to do. But if you ever did want to do crazy things, it is just a Rust program. So there's a lot of flexibility and things you can do. But I was certainly able to get up and running without a whole lot of work. A lot of what might make things a little bit difficult is needing to convert from like a Soroban environment, an XDR, into a native Rust environment. But there are a lot of these helpers. So things like address to alloc string, that the Zephyr the Zephyr SDK. So there's a Zephyr SDK that's provided. And it provides a lot of these utils like address to alloc string. Those would be the only pieces that are like, oh, I'm not actually sure how to get from Soroban string to a Rust string, so that something like Serde could actually turn it into JSON. But there are a lot of these helpers that TDUP has built into the SDK that make dealing with that stuff much, much easier.
Awesome.
Yeah, someday we'll have to actually do some like hardcore Rust programming. I've been working, again, I mentioned this last week, so apologies for the repeat, but I've been doing a lot with these, the Stellar Global Discord has been popping off on these proof of work assets, and I've gone deep down into the rabbit hole. It's like when you're in Minecraft and you start digging a hole and then it opens up into one of those caverns and you're like, well, I guess we're here now. That's what's happened to me over the last couple of days. This is my life. I'm a miner now. So that has been happening to me, and it's super interesting, but it has expanded pretty tremendously my Rust knowledge, because I've had to learn about things like threads, and I took a stab at writing a GPU program for Rust, and it didn't work because Rust doesn't have great support for GPU stuff. But it's actually a lot of fun as you start digging in a bit more to Rust. And but as far as the Zephyr side for Soroban, like, I think you'd be surprised probably how good of a Rust programmer you actually can become just writing Soroban Rust, if you write it long enough and start really trying to optimize for things like speed and efficiency and size, because that's what a lot of Rust programming is in other places, where you're thinking about byte packing. And once you get to that level in Soroban, you'll find a lot of the other Rust writing stuff is not actually too terribly complicated. At least in my experience. And I am coming from a world where I wrote jQuery for many, many years, so the bar was low.
Gotcha. Yeah, back in the good old days. As far as context for that question about indexers versus like ledger state, data entry keys, that kind of thing, I think coming from like the classic side of Stellar, I've always been like, essentially, I'll admit to being one of the bad ones, that Horizon has been kind of like the back end for a lot of the stuff, as far as like balances or even managed data entries on an account or something like that. Soroban opens up like this world of possibilities where I could put important or not important data into events or ledger state or contract state or whatever, or just kind of, if somebody's interacting with my front end, kind of stash that into a SQL database if I wanted to. So like the world of possibilities has expanded. What are some like ways that you determine this piece of important information should be an event, this piece should be stored in contract state, the different options?
Yep, good question. And it has a lot, like, once you start asking that question, it trickles down into a lot of other questions. I'm going to stop streaming for just a minute because it's chat time.
Chat time.
I'm also going to pop this out so I can feel like I'm talking more normally, I guess. Wait, why didn't that work? Well, forget that. So essentially, the question is like, how do you determine what should go in a contract, what should be emitted as an event, where should it be stored, why, like what's the logic for understanding where storage goes and what type? Because once you start, the other question then becomes like, okay, now I've made my decision, or maybe part of that decision is also like, oh, there's like 3 different types of storage: instance storage, persistent storage, temporary storage. What goes where? What's the logic for understanding these things with events? Now you've got shadow events, and you've got Soroban events. You've also got return types, where you can just return information, and then I guess you could store that. So there's a lot of different ways to like get data out of the blockchain, leave data in there. I think the way that I think about it is basically you want to store. I want my invocations to be as cheap as possible. That's like the bottom line. Is don't pay for stuff you don't have to. Like, okay, maybe not everybody's going to use my protocol, and so the cost will be not that big a deal. But like, I don't like planning to be unsuccessful. I'd rather plan that this is going to be wildly successful. It'll be invoked billions of times, and if it was, what changes would I make to improve efficiency? Now, there's obviously a balance on you need to get this thing launched, so you can upgrade it at a later date. But there are some like significant design decisions that will change the way you actually build the protocol itself if you're storing something on chain versus storing something in event. What I might mean by that, for instance, would be if you store something on chain, you can then read it later as, env.storage.get or persistent get, instance get, temporary get. If it's an event, that data will have to come back in some other way through an argument. You'll pass it in as an argument. So when I'm thinking about where do I want to store something, if I can keep it off chain, I'm keeping it off chain. I can always pass in more arguments. So then the question is, what belongs on chain? And it's really just it's only the stuff that the protocol actually needs to be like secure, decentralized, that shouldn't have like an owner, shouldn't be able to be tampered with. And I think what I have found that when you start thinking about it like that, there's actually usually not actually that much that needs to be, not nearly as much as we would think. There's like information that's on chain that's like, that would be nice if it was on there, right? It'd be more convenient to be able to access it easily if it was on chain. But it's not like the protocol isn't secured by that information. Like if I passed in a random value, nobody's going to lose money. It's just, man, it's going to be hard to find the right value. But if somebody passed in the wrong value, the invocation would fail. Nobody's going to lose money. And so that starts to signal this probably doesn't actually need to be on chain. We just need a good way to track what the right argument would be, so that when somebody comes back to the system, they know what value to look up. So don't store stuff for convenience, store stuff for security. And I think you'll find that you actually have to store way less stuff on chain than you thought you did, and you actually need to think about indexing a lot more. Yeah. So an example is the passkey kit. Signers are stored on chain, but a mapping of like a reverse lookup, it's very important that reverse lookup be able to happen, where given a signing key, you're able to find what contract it's associated with. But that's actually a really hard problem to solve on chain without an infinitely growing map of mapping an ID to a contract address. And so now the question becomes like, okay, I've got a key, but how am I supposed to find what contract it's associated with? And that's where you could store it in a map somewhere on chain and then say, okay, I'm looking at this map and I see all the keys that are associated. There we go. I've got my information on my database from my database. But there's nothing about that secure. Like the worst thing that's going to happen is like, okay, you sent us a key, but it's not for the right contract, not for the right contract, not for the right contract. So it's inconvenient to have to like guess, but it's not a security issue. And so that information should actually be stored off chain. And then we need to solve the problem of, okay, but how do we actually store this information? And that's where indexing comes in, and specifically where events come in, is that you're always emitting when a signer is added to one of these smart wallets, that you're saying, hey, this smart wallet just added this signer. This smart wallet just removed this signer. And that's always emitted as an event so that you could go back into an indexer and say, run back the blockchain and build out a new database with, it's a centralized map, but who cares? Let's say they're nefarious and they map the wrong addresses. The worst thing that's going to happen is the contract's going to say, hey, I see you're trying to do this, but we're looking on chain and it's not right. So it's not authorized. Invocation failed. And so I'm fine, like, okay, inconvenient, but not security issue. And so now we just need good indexers. And that's kind of where I land, is store as little as possible on chain and as much as possible in events, indexes, return types, so that you don't run into that issue. There obviously are things you have to store on chain just from a security standpoint, that if somebody, but the question is, like, if somebody were to alter the information, alter the arguments, is someone going to lose money? Like, is something unacceptable, something bad going to happen? If so, that should probably be stored on chain. So things like, who's the admin of the wallet? That should be stored on chain, because if somebody's like, I am, and you're like, well, I don't actually know if you are, but I'm going to assume you're telling me the truth off of the argument. Then they just took over your wallet. So that needs to be stored on chain. We're working with these proof of work assets, and it stores like its own index. Every time a block is closed and rewards are issued or emitted, the index of the current block, that needs to be stored, because you don't want somebody passing in an index that's like, we're technically on, block 1000, but I'm going to mine for block 2. If you don't have anybody to say, like, well, the actual, like, official source of truth is that it's 1000, I guess we have to believe you that it's 2. So yeah, there's certainly obviously things that have to be stored on chain, but do as little as possible, because it will be so much cheaper to store it off chain. The second piece then is, when you do store something on chain, where should it be stored? And again, I'm going to always default to, if you can use temporary or instance. Well, if you can use instance, that's going to be the cheapest. Instance storage, you always get for free, in the sense that it's attached to the contract itself. Instance storage is persistent storage that's attached to your contract. So when you deploy a contract, it gets its own, like, bucket of instance storage. And every single time you invoke your contract, the entire instance object is, like, hydrated into the invocation. So anything that gets stored in an instance storage automatically gets hydrated into your entire call stack for free, which comes with a benefit and comes with a cost. The benefit is you don't ever incur additional cost if you're storing, like, a lot of different keys. And you're like, oh, I need to read this key and this key and this key, and I've got 10 different keys on my instance storage. That's going to get expensive, right?
Right.
It won't, because they're already all hydrated. It's just basically like saying instance dot. You're not loading up. It's not costing you anything additional to.
It's not reading these extra entries.
That right, exactly. The entry. All the entries come from contract instance. That's the entry key. The cost is, don't store too much in instance, because every single time you make an invocation, even if you don't touch those instance keys, they all get loaded in. So everybody has to pay to load in all of the instance keys for every single contract invocation, which is, don't store things in instance that you're not willing to have every single user for every single invocation pay for every single time. So keep instance storage to an absolute bare minimum. Like, the less you can store there, the better, in the sense of everybody has to always load this. So things like admin keys, those should probably go there, because you're going to have to call that a lot. If it's like an asset related contract, everybody's going to have to read in that token to know, like, what token are we dealing with. So that one can go there. Things that typically every invocation or every user is going to need to read, that's what belongs in instance. So then the question becomes between persistent and temporary. And I've been finding, like, the idea behind temporary was kind of like, just put nonce keys there for authentication, or, don't really use it that much. But, prefer persistent, and temporary is really just for temporary entries, which I get. But I think there's value in, like, if you can put it in temporary, it is so much cheaper than persistent right now. But don't put anything like that you actually need to survive, because once it's gone, it's gone forever. There's zero shot you're getting that thing back.
Can't restore.
with like maybe two caveats. First is like that's often okay. There's honestly not. There are certain things certainly that need to be there for a long time. But even if you're like, well, temporary is like 2 hours, and it'll be really really bad if it doesn't exist. But like people will lose all of their money if it doesn't exist. But that's fine. It's not a big deal. It's 2 hours. So long as it happens in the 2 hours, like, okay, but what if something happens with the chain and something goes down for 2 hours, or, you hoped that people would respond back, but the internet went out. And they weren't able to call the blockchain for those 2 hours. Like bad things could happen if you store important, like critical information in temporary storage and then it expires and gets evicted. So be really careful what you store there, with the understanding that it's actually really nice. It's super, super cheap. And to have this concept of like, I could store something and then it just goes away. Like it doesn't clog up the blockchain. It's cheap for my users. I wonder what I actually end up really needing. Like what's the worst case scenario if this thing were to be evicted? And in many cases, I am again finding that it's not an unacceptable, it's just inconvenient, where like you have to recreate a value versus the whole protocol breaks or people lose money because something got evicted. You just have to create logic that says, hey, this thing's evicted, let's rehydrate it, let's add it back to the chain. You won't be able to find like what you should reactivate it to necessarily safely unless you've been storing some items in like instance storage, for example. But there's some interesting strategies there where you can, like, the most important information gets stored in persistent or instance, and the day-to-day operation items like that keep the protocol running. But yeah, if something breaks, it could just get recreated or what have you. Those could be stored in temporary. There's a lot of usage for temporary entries, I am finding. And again, like with temporary, you can bump it. So it is possible to say, even though it does expire in 2 hours or whatever it is right now, that there's nothing that says it can't be bumped to be like 6 months. Again, be really careful with that. Don't rely on temporary storage that you hope will be there. And if it's not, everybody loses their money. But there is this ability to, just because it's called temporary doesn't mean it's like short-lived. It could be long-lived. You could bump it forever. But if it's sort of this heaven help us if we can't actually bump it, that may be a signal that you should be using persistent storage. And then finally, persistent storage is also awesome. It's like our classic blockchain storage. It just exists forever, but it is kind of expensive. And it should be expensive. To expect things to exist forever is kind of wild. And obviously we have state expiration, but even that is like, it's somebody's still storing something. And if you want to rehydrate it, somebody's got to keep track of it. Now, not everybody maybe has to keep track of it. But yeah, if you don't have to put it there, don't put it there. And it's always going to be more expensive than temporary.
Gotcha.
So anyway, those are some of my thoughts. And it is a ton of fun to play around with the implications of storing things in different places. And I've just generally tried to move away from a persistent storage first mentality to a more holistic events. Let's try and use events for everything. If it's going to have a DApp somewhere. Okay, there are certainly things that aren't going to work for that. So let's roll it back to, could this be an instance item? Could this be a temporary item? Okay, if I have to, I'll use persistent. But trying to write more and more of my apps with a more holistic understanding of the pros and cons of each type of storage, and that will really change the way you build out your protocols, build out your contracts, when you have this understanding that it's not just a database, but there's many different types of storage that all serve their own unique purposes and have their place in development. Makes
sense. If I were to develop something with a data indexer in mind, is there a way, is events are the primary way to get that information into indexers? Is that right? Like Soroban emitted events.
Typically, yes. So there are more indexers than just Mercury, but all of the indexers at least will be expecting events for ingestion.
Okay.
With Mercury VM, you actually get access to the entire ledger close. So I've got this color glyph indexer, and you'll notice that my loop here, when I start processing things, is actually, let's see, it's process transaction, which is coming from the envelope. It's actually coming from envelopes with meta. So it's actually looping over transactions in the ledger, not events. So this particular indexer for Mercury, I'm sorry, for the Zephyr VM, is processing transaction envelopes. It never touches events, which means that my contract can actually be kind of cheap because it never emits an event that it doesn't absolutely have to. Because you can get a ton of information just from transactions, like what transactions were, or what contracts were invoked, what arguments did they pass, was it successful, or what did it fail. There's you have access to like the before and after kind of ledger keys, so you can see what something was and then what something is when the block closed, which is all really helpful information that kind of means you don't have to use events. But this is also very specific to the Zephyr VM. So it's not a bad idea to emit both. But in my case, for color glyph, I'm emitting a lot of changes to stuff, big changes to stuff. And so those events were actually pretty expensive. And they're like duplications because I actually have all of that information in the transaction meta. So why would I emit both? It would, I'm not going to be able to use whatever indexer I want. But I could use one that allows me to have access to the transaction meta and then parse all of the information that I need for those operation, like what they actually changed. I can look at that information and then process it. I mean, you can see when you run a program this way, it goes from 200 lines of code to like 600 lines of code because you have to process information a little bit more heavily. And again, this one's more complex than the passkey one, but it's entirely possible to process transaction meta versus just events. So kind of to roll back to the original question, it's a good idea to emit events, especially if you want more options in how your events get processed. Like the RPC is going to deliver events. Most of the other indexers are going to deliver on events. Here's all your events. But if you want something more complex, it's not necessary in the sense that Soroban transactions emit meta that has all of that information anyway. So events can kind of be this duplication, but the model that we have out there in the world is let's use events for data. And so until that changes, we're going to continue to use events, but there will be, like in my case, this is not it's meant to be used by a specific front end. It's being processed by a specific back end. It's like it's a decentralized application or contract with a pretty centralized front end. So I was okay with this idea of, if you want to build an indexer, you're going to kind of have to either use Zephyr or write something custom because it's not emitting a lot of events because it would have been really expensive for what I was trying to do.
Gotcha.
It's going to need to process transaction meta.
That makes sense.
Good question.
Are events like typically how it's done like in other blockchain ecosystems? Okay.
Yep. And they're getting kind of expensive in certain blockchains, which is where this idea of shadow events like that. That's not unique to TDEP or the Zyclu guys. This concept exists in Ethereum, where you have like a side network. It's not a side chain, but it's like it's a parallel network that runs alongside the main network, just with different or expanded contracts, if you will, that as it's executing line by line the WASM or the bytecode, opcode of the contract, when it runs against one of those shadow events, it emits it, populates a database on the parallel network. And that means that you don't have to emit events on the main chain. You can just have raw contract stuff. And then in that parallel chain, you've populated it with events that are free, essentially, because it's running in a centralized environment. Now, it makes a lot of sense because events are not mission critical. They're informed. They're like data. They're information. It's not going to be that consequential. It'll be like inconvenient, but it won't damage the protocol if those events don't get emitted or if there's a time delay between them. you may want different parties to be involved in like processing that information. But yeah, if it's a centralized third party indexer processing that information, that's fine. So in that sense, why are we emitting events as a decentralized event and everybody has to pay for it versus just one computer running the parallel network? It's going to be a lot cheaper to process that event.
Makes sense. Silence has a question.
Talk about like upgrade contract, how to make sure the storage works on the new one. I mean, that all depends on how you're doing storage. I actually kind of have run into this when I upgrade a contract and I've like significantly changed my like keys. You just have to be careful. If you're going to like upgrade a contract on mainnet, you're probably going to need to also include some sort of like migration function that will take data from an old key name to a new key name, or, you know, delete information that's no longer relevant and populate it in a new format or whatever. That's probably going to be a model that I'll start adopting. Would be some sort of like migration V1, migration V2 that's written to transfer data from an old standard or format to a new standard or format. Yeah, that's probably the way that I'm going to end up doing it. But yeah, if you're upgrading a contract and significantly changing things, you maybe should be using a new contract as far as like mainnet is concerned. But that's probably a larger philosophical question. But yeah, your contract will break if you've significantly changed it. There is like some testing. It's why we have, when you run a test, you get that test snapshots or whatever. And the idea was you can like write a contract, run your tests, commit your test snapshots to get version control. And then when you upgrade your contract or change your contract, you can look at the diff between the tests that ran before and the tests that run after and kind of get some sense of like, oh, okay, yeah, we're adding a bunch of new ledger keys. And here's the old ones, here's the new ones. Okay, great. I'm going to need to create some like migrations between these two things to like move data. Will a constructor work with the upgrade? I don't think so. I think constructors are only fired once on contract deploy. I could be wrong. I haven't followed that too closely. I'm sure it's been discussed. Maybe someday we get a _ upgrade or upgrade constructor or something. I'm not sure. You'd have to look at the actual cap that's being written for that. But I think it would be very bad if a constructor got called twice.
Second time.
Without very explicit controls. I'm just reading through these. I guess it can be permissionless. Yeah, you just need to be careful. Like, don't upgrade contracts until you understand what it is you're doing. Again, I think a migration strategy that continues to have access to those controls. And it's not like it's like, come on, guys, it's super obvious. It's actually not super obvious because traditional computer programming doesn't work like this, where it's like, hey, you've got data in your database, but it's impossible now for you to access it. So sorry. You just be like, oh, shoot, I kind of forgot about that. Yeah. I'm going to need to go back, update my program, and add those new features back in, which I guess in some sense, so long as you continue to have the upgrade function, you could be like, yeah, shoot, I forgot about the migration strategy. Hopefully it's not too late and things have just been failing. And you can go back and, create a migration function and then update things again. But yeah, you'll probably like the problem with upgrading is like the idea is we probably need an upgrade function, but it also runs a little bit counter to the whole immutable thing. So we need to just remember that as we develop contracts is don't develop with the idea that I can just upgrade it later. It's supposed to be immutable.
Yeah.
We allow this functionality for it not to be, but don't get lazy with that. Be intentional. Like if you start upgrading stuff for folks and it breaks, I just know of no faster way to make sure nobody trusts you for anything ever again. So particularly like on mainnet, don't just start upgrading contracts without fully testing what the implications are. And again, that's what those test snapshot things was for. So that you have a good suite of all of these tests that fully test your contract, creates a test snapshot, and then you run it again whenever you change the code and see what all changed. And wherever there are significant changes, you'll need to create some sort of migration strategy. And oftentimes, probably the better thing to do will be just create a new contract address. Don't try and upgrade. If you've got owned assets or something, you'll need to include like a migrate asset admin or something like that. But it's like contract immutability is not unimportant. I think it's very important. And there needs to be more explicit, like, hey, everybody, we're going to be moving. If you want to stick with the old one, you can, but we have this new contract address if you want to start using it. Or we're going to put it here. We have a migration thing, and they're going to have a DAO vote on if we want to migrate the assets over. Or we're going to upgrade, but everybody has to review the code for 6 months, and then we'll move over. Again, pretty foreign to traditional programming and traditional, tech. But we're operating in a decentralized, immutable environment, and we just need to behave like that. Cool. Anything else? We actually made a full hour out of chit chat with Elliot and Kalepail.
Don't see other questions that haven't been answered already.
Sweet. Well, I'll make sure and read back through everything. And if there's anything else, I can reply to it directly. But appreciate folks hanging out. It is a very exciting time. AI, smart wallets, this Zephyr VM. Hopefully I can get a demo of that maybe next week or at some point. But it's a very exciting time to be a Stellar developer.
Heck yeah.
Yeah, as people have questions, feel free to drop them in the chat. I actually have a doc. I'm not sure I want to let everybody have edit access to it, but you can always DM me or Elliot with topics you'd like me to cover. The idea is that this is our space for you to get your questions answered and dive in a little bit deeper into the Stellar Soroban ecosystem.
Yeah.
Yeah, no mention of Kale. All right, fine. I can't mention Kale without also mentioning its father, Stellar Corium, which just got a big upgrade. Again, this has just been a really fun project, these two, and I strongly encourage any brave soul to go and play with these two proof of work assets. I mean, these are super, super interesting. I just launched my version of it, which is Kale. So you can go and mine Stellar Corium or you can farm Kale. They're two different takes. Mine is a proof of teamwork, where Stellar Corium is more of just a proof of work. But he has made the guy behind Stellar of Expel is working on that one. So very solid, super cool project. Just put a big update to that. So I still actually need to read through what all the changes were, but it's been a lot of fun. It's like this weird balance between making GPU KEK miners and Stellar transaction submissions with sequence number timing. It's almost, I don't know, it reminds me again of those Stellar Quest days when you're just trying your hardest to get something that seems like it should be so simple to actually work. That's all happening over on the Stellar Global Discord. Strongly encourage everyone to go and play around with that. There's miners, so even if you're not a programmer, we've had a lot of folks that are like the guy who builds Lightmint, Fred. He's been writing us miners for these so that we don't have to like put in too much work on our own. He'll get it started and then people will start improving it. It's just been a lot of fun. It's like it's interesting take on a proof of work asset. So it gets mined slowly over time as people meet certain like hash requirements, and every 5 minutes or every minute new assets get issued. I'm actually really interested in taking another approach, or taking like an expansion where inside of a Soroban function you can call other functions, right? It's a cross contract call, but you can provide it arbitrary arguments. So it's like you include an argument that is like an array of arguments, and then you could provide another contract hash, which essentially could say, you can call contracts inside of one of these contracts. So a contract call calls another arbitrary contract call, which then would be this interesting like potentially side chain L2 maybe network, where it's like you have contract invocations that happen inside of contract invocations as part of this proof of work protocol. It may be really, really stupid, but it was an interesting idea that if you wanted to like use these assets for actually processing transactions, you could build a function that calls other contract functions, but that require a little bit of these tokens that you've mined. Why you would call those functions instead of just calling them on the main chain, I guess you wouldn't, unless of course XLM or something got really, really expensive, like Ethereum did, and then you've got to have these like L2s that process batch transactions, and then it becomes like this, like, okay, we're not actually using main Ethereum, we're using these side chains which actually execute these arbitrary functions that do like roll-ups of some sort. I don't know. It's highly experimental, but it was kind of, I don't know, one of those shower thought, like, I guess you could technically create a more expensive side chain than the main chain by having arbitrary transaction executions that happen inside these proof of work machines. But anyway, all of that to say, you should get involved in both of these projects. They're super fun. And I'm handing out launch tubes. So one thing with these is that they do end up, you have to invoke you have to send transactions quite a bit, which then can run up your old XLM bill. But I'm more than happy to give away mainnet launch tube tokens, so you can submit transactions on chain on mainnet for free. So I've converted all of my miners over to using LaunchTube. So be sure and reach out. You can send me a DM. Elliot also has access to give people LaunchTube tokens, so you can bother him as well. Bother us both. We don't talk to each other. You can just go and get yourselves as many of these LaunchTube tokens as you... Hey, get 20 of them and then sell them for FCM. I don't care what you do with them. The idea being, let's all have a bunch of fun playing and learning Rust and not spend a fortune when our miners crash and we have to pay XLM for failed transactions. All right. That is it for this week. I will catch you all hopefully in the Stellar Global Discord or around the town, as it were. Y'all have a great week.
Bye, everybody.